GameSci.com. GameSci.com.
Hi ho, hi ho, it's off to program we go. Let's do this. PHP file I.O. Data in RAM memory is transient. It disappears when the program ends or the computer powers down. However, data on the hard disk is persistent. It exists after the program exits or after it powers down. You store data on the hard drive and it sticks around. You store data in the RAM, it disappears. PHP file I.O. I.O. stands for input and output. Read and or write data stored on the server disk file. We're going to start easy. Functions that read or write in one function call. It's sort of eating the whole sandwich in one bite. This is the PHP file function. It reads the entire contents, and each line of the file is assigned to an array slot. Data moves from the disk file, here, into RAM memory into an array. This config.ini file, it must be in the same directory as the PHP program. I don't do any file path in front of here, so it's got to be in the same directory as my PHP program. But what we just did there is we swallowed the entire file from the disk drive and put it directly into an array in RAM memory. Let's do a simple for each loop through each array element or each line of the file. $1 line equals file array 0. What this syntax does is for each item in the file array, assign the first item to $1 line. And you can see that very first item, slot 0 of the array, got assigned to the variable $1 line. We just took a slot from the array and assigned it to the variable 1 line. That's what the for each loop does. Take every item out of here and assign it one at a time to $1 line. There are lots of ways to process this data once it's in the array. I decided to use a for each loop. Print $1 line, and you can see it shows up here on the output. We're basically going to dump the file contents to the page or the screen. Each print is one line from the file because that's what the file function does. We've also reached the end of the loop here, so we'll loop back up to the for each loop. Going to the next item in the loop, this simple for each loop through each array element or the next line of the file. This time $1 line will be assigned file array of slot 1. You can see the data at index 1 is assigned to $1 line. Note how it automatically advances to the next array slot or line of the file. Print $1 line, and you can see the output from the $1 line variable comes out onto the screen. Dump the contents to the page or screen. Each print is one line from the file. We've also reached the end of the loop. We'll spin back up and execute for each again. For each file array as $1 line, a simple for each loop through each array element or the next line in the file. We will now assign what's in array slot 2 to $1 line, and you can see it shows up in the $1 line variable. $1 line equals file array subscript 2. The for each automatically goes through each slot of the array. Print $1 line, and it comes out onto the screen or output. Dump the file contents to the page or screen. Each print is one line from the file. We've once again reached the end of the loop, and we'll spin back up on the for each loop. This time it's different though. For each evaluates to false in this case because we've run out of data in the array. When the end of the array is reached, the for each loop will return false and the loop will exit. Also, it's the end of the if-else statement above it, so we'll move to the next if. This statement went false, so we exited the for each loop. We hit the else statement, so we skip past the else to the next line of code. Before I move on though, let's take a closer look at this else statement. Even though the else is skipped, it's extremely important. There are 100 reasons why the file command will fail. File not found. It's not in the same directory. There's no read permission on the file. There's many different ways that this line of code up here will fail. We need this else statement for the situation where this line of code did not work. It'll execute the else and tell the user. Always check, and at the very least, print an error message so the user knows that the file was not read. Next command. This is another command in PHP. which will read the entire contents of the file. If $file string equals file get contents, and this time let's go to a new file, user.txt. File get contents is the name of the function. It reads the entire contents and assigns the result, the whole thing, to a string. Everything in the file user.txt is assigned to a string variable, not to an array, but to one single string variable. And you can see everything in this file basically got dumped into this string variable. The data moves from the disk file to RAM memory. User.txt must be in the same directory as the PHP program. With no directory information in front of this, this is expected to be in the same directory as your PHP program. Both the commands file up here and file get contents read the entire file into RAM memory. Assuming file get contents work, let's go to the next line of code inside the if statement. It'll only come down here if the line above it worked properly and returned true. $file str equals bump level and pass it file str. The function searches $file str for level equals and adds 1 to the 4 and replaces it with 5. I'm not showing this function, but it's a simple function that takes the level and bumps it by 1. It started out at a level equal 4, and all this function does is change the 4 to a 5. Now there are several ways to code this. This example calls the string functions, but there's plenty of different ways to do this. Also note the \n characters from the file will be in file str. There is an end of line character here, an end of line character here, an end of line character here. When it's in a string, you really don't care about the end of line character, but it is there. I don't show this function. All it does is bump whatever the level numbers is to the next value in the sequence. 4 got bumped to 5. What I'm doing here is I'm taking that data, that information that was stored on the hard drive here, I suck it into RAM memory so I can make changes to it. $file str equals add score, pass it file str and a -25. Function searches the $file str string for score equals and adds -25 to 123 and replaces it with 98. What I'm doing with this function is changing the data for the score in RAM memory. Since it adds to the score, the -25 will make it back up 25, and if you do the math, the 123 from the file minus 25 comes out to 98. Again, there are several ways to code this. This example might call string functions. However, there are many ways you can change the data once it's in RAM memory. There's \n characters in $file str. Even though the else is skipped in this example, it is extremely important. This is error checking, and you always need to do error checking. There are 100 reasons why file get will fail. I don't like the way I formatted this code. I was running out of room. But always check and at least print an error message when a file operation fails. By this point, we read the data from the file into RAM memory. We changed the data while it was in RAM memory, and now we're going to write it back out to the disk. If file _put _contents, pass it the file name and the file string. This is the file put contents function. It writes the entire contents of the string to the file. In this case, the data moves from RAM to the disk file. So I'm taking the data out of RAM and writing it back to the disk drive. And just like we read it in one gulp, we're going to write the whole thing back out in one gulp. That's what the functions on this screen do. They read and write the entire file with one PHP command. Important to remember, user.txt must be in the same directory as the PHP program. Without any directory information in front of user.txt, it will default to writing to the same folder or directory. If the command worked, and in this case, let's say it does, I'll just print a message out to the screen to notify the user that the update worked. This is a simple print to verify the write to disk work. If the function file put failed, it would return false. If this prints, then it did not fail, I can tell you that much. However, you always have to be concerned about errors when it comes to file read and write. Even though the else is skipped in this example, it is extremely important. There are 100 reasons why file put would fail. All three of the else statements in this example, the else here, and the else there, they're all doing much needed error checking. You should always check and at least print an error message when a file operation fails. There you have it. Those are two functions that read the entire file at once and another function that writes the entire file back out to disk. Notice a pattern here. We take the data, we read it into RAM, we change the data while it's in RAM, and then we write it back out to disk. That's how file I/O works. Sequential file I/O, input and output. Functions reading the entire file are specific to PHP. Not every programming language reads an entire file at once. And keep in mind, reading in the entire file is for small files only. You're not going to do this with extremely large files. So let's look at another way to read and write files. Most languages have an open, read, write, and close pattern for file I/O, where you open the file, read and write to it, and then close it when you're done. The code on this side is very similar to the type of code you'd write in C, C++, or Python when doing file access. The file command and the file get contents, those are kind of PHP commands. This is the way most programming languages read and write files. Sequential file I/O. Sequential access files means data is read line by line. To get to the end, you must read every line. Sequential access means we'll start at the beginning of the file and we'll work our way through every line of the file until we reach the end. The data at the start of the file must be read before the data in the middle of the file, which must be read before the data is accessed at the end of the file. Sequential I/O means I will sequentially access all the data in the file. If $fd equals fopen players.txt, R. This is the file open function. Note the bold letters, F in file and then open. Fopen is the file open function. This command does not do the read write, it opens the file for access. $fd is the file descriptor variable. FD is short for file descriptor. It's a variable that tracks the information in the file. It's very important to have this variable. It is a more complex variable. This is not a simple variable. It contains multiple pieces of information about the file. The second parameter here, the R, stands for read access. We want to open this file for reading. There's a parameter W for write access to the file. Be careful with this one. It deletes the current contents of the file. And there's an A access mode, which is append. Means I want to add data to the end of the file. If I'm planning to write to the file, I usually use the A option instead of the W because it doesn't delete the current contents of the file. It adds to or appends to the contents. The players.txt file must be in the same directory as the PHP code. If you do not list any directory information in front of the file name, it assumes this file is in the same directory as your PHP program. Before we leave this slide, notice that the $fd variable, which is in RAM memory, is tracking the name of the file, the byte position in the file, and the access mode. I'm sure there's much more data in the $fd variable, but this is what I want to highlight out of it. While not FEOF and pass it the $fd parameter, this is the file end of file function. Notice how I bolded the letters. FEOF stands for file end of file. The FEOF returns false when the data is still left to read in the file. Then the not false keeps it in the loop. So if there's still information to read in the file, this will return true and will go into the loop. When we reach the end of the file, this will return true We're at the end of the file. The not true will make it a false and we'll exit the loop. The $FD file descriptor tracks where the file pointer is. Each read automatically advances the pointer. $1line equals fgetS pass it $FD. This is the file get string function. Notice the bold letters FGETS. This is short for file get string. This reads a string from the file up to the end of line or \n character. So what it did is it read the first line of the file and transferred it to the $1line variable. Also notice that this arrow right here is the file pointer. Move the file pointer to the next line of the file so the next read occurs at that point. Sequential access means the file pointer $FD moves to the next line. I use X as sort of a variable here to indicate that I've moved to a different byte position in the file. This is the file input. Read me data off of the disk file. $REC equals explode, passing it a comma, and the $1line variable. $REC is short for record. We're reading one record out of the disk file. The explode parses the string using the comma delimiter and returns an array with each element in a slot. The explode function says look for commas and separate the data in $1line on the comma. This is comma separated data. It's a common text file format. See that comma right here? It means this, John, goes in record subscript 0. And then after the comma, Doe goes in record subscript 1, comma JDog goes in record subscript 2. It's called parsing a string. We are breaking up this string into its 3 individual pieces, and what explode does is it assigns it to an array variable. Let's just print out the data that we loaded into the array on the previous line. Now, I ran out of room on this slide. I never have room to put the code that I actually want. I always have to short it. So I did abbreviate the output. If I had room, I would have loved to said first name and then printed out record 0. Last name and printed out record subscript 1. Screen name and printed out record subscript 2. But I didn't have the room, so I just shortened first name to F, last name to L, and screen name to S, and that's what I printed out. The first name is John, the last name is Doe, and the screen name is JDog. Notice also we have now reached the end of the loop. After this print statement, we'll hit this curly brace. That curly brace will spin us back up to the while loop. While not, file end of file. Notice the highlighting on these letters. FEOF stands for file end of file function. File end of file returns false when there's still data left to read in the file. So the not false makes it true and keeps it in the loop. The $FD file descriptor tracks where the file pointer is. Each read automatically advances the pointer. It is internally keeping track of where in the file we are currently reading from. And this arrow right there says we're about to read this S in Sioux. $1line equals fgetS. File get string. Look at the bold letters. This is the file get string function. It reads a string from the file up to the end of line character. The end of line character that would be after the word cat here. Read this entire string, load it into the $1line variable. Sequential access means the file pointer $FD moves to the next line. I use byte Y as a variable here to say, hey, I just adjusted the file position in the file, so the next read will happen on the next line. This is file input. I read one line, and then the file pointer moves to the next line, getting ready for the next read. But before we get there, let's explode it. $REC is short for record. Take one record and parse it or explode it using the comma delimiter, and it returns an array with each element in the slot. So this comma parameter says read up to the comma, take Sue and put it in record 0. Take Kim and put it in record 1. Take Cat and put it in record 2. Explode chops up the data using the comma as a delimiter. This is comma separated data. It is a common text file format. Look at this file up here. Each line is a record from the file, and then each field within the record is separated by commas. Explode will parse the data, separating the data out at where there is a comma. Simple print statement. Once again, I ran out of room. I had to abbreviate. This F is short for first name, this L is short for last name, and this S is short for screen name. And you can see the data that was read into one line, parsed into the array, is now output as first name Sue, last name Ken, screen name Cat. We've also hit the end of the loop. This curly brace right there marks the end of the while loop, so we'll spin back up to the while loop. While not file end of file. File end of file function returns false when there's still data left to read in the file. And if you look at this pointer, we still have data left to read in the file. The not false makes it true, which will keep it in the loop. Who's tracking all of this? Who's tracking where we're in the file? The $FD variable is tracking it. Part of it says I'm at position Y in the file. That's where the next read will occur. Each read automatically advances this pointer to the next item in the file. This is still a true statement, so we'll go into the code and we'll do a $1 line equals fgetS. What does fgetS stand for? It stands for file get string. Get me the next string available in the file and assign it to $1 line, and there it is. Sequential access means the file pointer $FD moves to the next line. I use Z as a variable here to indicate that I've moved to byte Z in the file. Now this could be 50 bytes in, 100 bytes in. It's the position in the file where the file read head is at, or the file pointer is at. Do keep in mind after this read though, we've kind of reached the end of the file. We just haven't tested for it yet. Because the first thing we got to do is explode it. $REC equals explode using comma as the delimiter. $REC is short for record. We want to explode one record of the disk file. Explode parses a string using the comma delimiter and returns an array with each element in the slot. So everywhere you see a comma, it's separating the data. Tim goes into slot 0, Win goes into slot 1, and Twin goes into slot 2. That's what explode does. This is comma separated data. It is a very common format when reading text files to separate the fields using commas. Simple print statement. Again, I'm running low on room, so F is short for first name, L is short for last name, and S is short for screen name. I'm taking the data out of $record or $rec and printing it out on the screen. We've hit the end of the loop right here, which means we'll spin back up, but this time it's going to be different. While not file end of file, this returns true when there's no data left to read, and I've reached the end of the file. I've read everything I can read out of this file. I hit something called end of file, and you see $FD is updated to show that it's now at end of file. When we reach end of file, this command will return a true. Of course, if that's true, the not makes it a false statement, and that false will exit the while loop. Do you see the importance of $FD? It is tracking where the file pointer is, and right now the file pointer is at end of file, so we leave the loop. fclose $FD. Notice the bold F and the bold close. This is the file close function. Notify the operating system you're done with the file. This is extremely important. I cannot stress enough how important this is. Open, read, write, and close pattern is typical with a lot of languages. This is how I used to open, read, and write files back in the days when I was programming in C. It's the same here as it is in a lot of other programming languages. It's a pattern. You open the file, you read or write the data in the file, and then you close the file when you're done with it. Now I'm going to skip the else because I executed the fclose. This else is attached to the if way up here. If this if was true, it went inside this loop, and when this loop is done, it will skip the else. Even though the else is skipped in this example, it is extremely important. This is our error checking. There are 100 reasons why fopen will fail. The file is not in the right directory. The file is spelled differently. Again, I don't like the format of this code. I didn't like putting the die on the same line as the else, but I'm running out of room, so I have to save space somewhere. The die command will exit the program. It literally tells the program to die, to quit executing. If you determine this file failing to open is a fatal error, you should go ahead and execute the die. It will print this message and then leave the program. Quite often, if you can't open the file, you cannot execute anything else, so you need to leave the program. But that did not execute, so let's move on. Let's do file open in a slightly different manner. $fd equals fopen, same name of the file, but this time we'll use an A as the second parameter. What did A stand for? It stands for append. This is the file open function in append mode. Notice how I put the word append here. We're going to append this file. Notice also that the file pointer starts at the end of the file. We are at byte end of file right now because in append mode you go directly to the end of the file. Add data to the file. Keep the current contents. Now I put a W with a question mark here and I put a W to note here. If you put a W right here instead of an A, it would have wiped out this 3 lines of data. It'd be gone. You'd be starting at the beginning of the file. But with an A, it's at append mode. It says keep the current data and append on to the end of it. If you follow the arrows closely, you can see what's happening. The file pointer is at the end of the file. So the next write will keep the current data and add new data to it. It's no accident that this arrow is pointing to the end of the file, and internally $fd is saying we're at the end of the file. fputS, this is the file put string function. Write data to the file. In append mode, it will be at the end of the file. We will add to the end of the file. Since we open for append mode, we will write to the end of the file. Notice the access append there. Notice how we're still at end of file. After we write this line, we will end up at the end of the file. The file pointer is still at the end of the file. Also, notice the \n right here. This is extremely important if you want to be able to open and read this file with a text editor. If you don't put \n's at the end of your text files, good luck trying to read it with a text editor. Let's call fputS again, our file put string function. Write data to the end of the file in append mode. It will add to the end of the file. Note the red letters that I put here in the data. I want to point out that this is buffered data. The operating system might not have actually put this data to disk yet. When you execute an fputS, it doesn't necessarily write it to the hard drive just yet. There's another step you have to do to make sure that the data is written to the disk, and let's do that now. fclose $fd. Now notice I took my data from red and made it bold. I am never guaranteed that the data actually written to disk until I force it to write it to disk. File close will notify the operating system to flush any pending writes to disk. Now I am certain the data is on the disk drive. This is extremely important. The fclose is 100% required. I never assume my data is actually written onto the hard drive until I actually do the last close. This is the open, read, write, and close pattern, which is typical of a lot of languages. This code here looks a lot like the C code I used to write many years ago. Lots of programming languages support the fopen command and the fclose command. That is a typical way to read and write a file. Even though this else is skipped, it's extremely important. There are 100 reasons why fopen in append mode fails. Again, I don't like the way I formatted the code here. I had to squeeze it to make it fit. But keep in mind, you should always do error checking. If this fopen fails, have an else statement that does something to let the user know that the fopen didn't work and therefore your writes did not go through. Die command, of course, will terminate the program. I've determined in this example that the failure to open the file in append mode should be a fatal error to the program, and I'll exit the program because I could not open the file for append. Phew, there we have it, sequential file I.O. All file I.O. is buffered by the operating system. The first fgets command that we ran, it didn't just read one line of file, it read the whole file into the operating system. The first fgets will buffer a block of data and dole it out to the additional calls. Same thing for fputs. It does not immediately write to the actual disk drive until the buffer is flushed or fclose runs. Disk access is extremely slow, so when it goes to read the disk, it reads a whole block of data in and then gives it to you as you ask for it. When you go to write the data, you write to a buffer. Technically, it doesn't get written to disk until you close the file, and then the buffer is flushed out and the data is stored on the disk. Random access files. Sequential access is not good when you only need to access a small amount of data in a large file. No one wants to read 500 megabytes of data to get to one record. Random access allows a program to jump anywhere in the file to read and write data. So instead of going through the entire set of data like sequential access does, random access says, hey, jump to this record and read just this record. Random access requires a fixed length record. What does that mean? It means each line or record contains exactly the same number of characters or bytes. We're going to use 50 in this example. So one line of data contains exactly 50 bytes or characters. Then the next record contains exactly 50 bytes or characters, and so on down the line. Each line of this file contains 50 characters or 50 bytes. This is extremely important for random access. If $fd equals fopen, and this time I'll open a file called dbase.db. This is a database file, and I'll use mode R+. So go open this file on the hard drive and return to me a $fd variable with a bunch of information stored in it, like the name of the file I have open, the byte offset that I'm currently at. With read plus mode, you will start reading at the very first letter of the file, or byte 0 of the file, and my access mode is read plus. $fd is keeping track of all the information needed to read and write to the file. The file open function to access the file data. $fd is short for the file descriptor variable, and the R plus is basically read plus or read write access to the file. We're notifying the operating system, not only are we going to read from this file, we're going to write to the file. That's what the plus means, read plus write. The file dbase.db should be in the same directory as the PHP code. $R is short for record number. We're going to set $R to 3. $size is the size of each record. It's 50 bytes or 50 characters long. These are just simple local variables. I don't like to hard code these numbers throughout the code. So it says we're interested in record 3, and each record is 50 bytes long. So I went up here and I kind of supplemented my picture on the hard drive. This record, John Doe, is at byte offset 0, and it is record 0. Now if each record is 50 bytes, at byte offset 50, there's the S in Sue. And this takes 50 bytes of data. So at byte offset 100, there's the record Tim. The T in Tim is at byte offset 100 of this file. And there's 50 bytes for that record. And then at byte offset 150, there's the K in K. And this is 50 bytes of data. So I can calculate record 4 should be at byte 200. That J is at byte offset 200. So this is the record number I'm interested in. This is the size of each record. Fixed length records are important for doing random access files. Each line or record is exactly 50 characters, so record 0 or R0 is at byte offset 0. Record 1 is at byte or character 50 offset in the file, and so on down the line. Record 2 is at 2 times 50 or byte 100. Record 3 is at 3 times 50, byte 150. And record 4 is at byte or character offset 200. It's a simple formula. The record times the size will get you to the byte offset for your record in the file. It's easy to calculate where a record number is located if you used fixed length records. And here we're going to use it. fseek to $FD, $R times $size. Record number times size will seek to the position you want in the file. Notice the bold letters here for F and seek. fseek stands for the file seek function. Move the file pointer to 3 times 50 or byte 150. In other words, to the start of record 3. Does everyone see that? 3 times 50 means move to position 150 of the file. And what's at position 150? The K in the start of this record. Also notice if you follow the line across, I've moved to byte offset 150 in the file, which is exactly the start of record 3 that I have stored on my disk drive. This is what we mean by random access. Move to any location in the file without reading the data prior to it. I didn't have to read all this data to get down to K. I said just jump to this position in the file. It does require fixed length records if you're going to do this efficiently. Once I'm at byte offset 150, I will say $record equals fread, pass it fd and the size variable. This is the file read function. Read 50 bytes or characters from $fd, that's our dbase.db file, and assign it to $record. Look also at byte 200. Once I read these 50 bytes into RAM memory, there are the 50 bytes in RAM memory. Once I read those 50 bytes, the file offset moved to byte 200, and you can see the byte 200 right there. I read the data into RAM, and I bumped the file pointer. This is a database record, a set of fields describing one player or user from an online video game. This is the first name of the player. This is the last name of the player. There's the screen name, and of course the ... just means there's more information stored in the record. And once it's in RAM memory, I'll just print the record. I'll print record number before my operation is this value. Print the record we just read from the file. So there's the data in the $record variable. I printed it out to the screen. Now I'm about ready to change this data. That's why I put the word before on the output. The pattern is the same from the last file, right? We're going to read the data from the disk drive into RAM. We're going to modify the data while it's in RAM, and then we're going to write it back out to disk. And I do a simple string replace where I replace K Fox with Bob Box. I don't know, seemed reasonable. It rhymed, so I made it rhyme. And that's what happened. The data in RAM memory that used to say K Fox now reads Bob Box. Read data from disk to RAM, update the data in RAM, then write the data from RAM back to the disk. This is a very simple update. You could have done much better example than I did, but I just needed to show changing the data because we're about ready to write it back out to disk. fseek. fseek stands for the file seek function. It says move the file pointer to 3 times 50 or byte 150. In other words, to the start of record 3. To replace a record, you must back up to the start of that record. When we originally came here, we read the record, which moved the file pointer down to the next line. All I'm doing is backing up the file pointer back to the start of the original record. If you're going to write or overwrite a record, you have to move back to that position in the file. $num equals fwrite and pass it the file descriptor, the record, and the size. This is the file write function. It says write 50 bytes or characters from RAM $record to the disk drive in the $fd file, which is dbase.db. It returns the number of bytes written. Look again, we're at byte 200 again. I went to this position in the file 150. I wrote out 50 bytes, and then the file pointer moved down to the next line, or byte 200. What we just did is we did an update of a database record to disk. But I'm going to put a little asterisk there. Why do I put an asterisk on that? Because never trust any disk write until the file is closed. Simple print statement. Let's print the record we just wrote to the file. I did not do it, but I probably should have done some error checking to make sure that I wrote 50 bytes out and print an error message to say I didn't print the 50 bytes. Again, I'm running out of room. I can't do error checking on every line of code I'd like to. But I do echo it out so the user has some idea that we wrote 50 bytes, Bob box. We wrote that out to the file. I showed it in red. That is the updated record. We read it into RAM. We changed it while it was in RAM, and now we wrote it back out to the disk. fclose $FD. This is the fclose function. Notify the operating system to flush any pending writes out to disk. So I changed it from red to bold text to say I updated it. Now I'm certain that the data is on the disk drive. The close function will make sure that any data that you have pending gets written out onto the hard drive. It's extremely important. fclose is 100% required at the end of any file writing. This is the open, read, write, and close pattern that is typical with a lot of languages, not just PHP. This is an awful lot like the code I used to write in C and C++. Even though this else is skipped, it is extremely important. There are 100 reasons why fopen read plus fails. If I don't error check, I won't know that my file was not written. Again, I don't like how I had to squish the format down here, but I was running out of room. Also, the die command will terminate the program. I've determined that this is going to be a fatal error. If this original fopen up here fails to work, I will jump to the else and exit the program with the die command. There you have it. In summary, we covered 3 different techniques for file input and output. Number 1, we looked at PHP functions that read and write the entire file in one gulp. Read everything in the file with one command. The second technique we looked at was sequential access using the open, read, write, and close pattern. This is done when we want to access all the data in the file. Read every single record. That's when you do sequential access. And the third technique, the one we did on this slide, was random access, where you can seek the locations in the file and read and write with no requirement to read all the data in. In sequential access, to get to JTOMs, I'd have to read all this data to read that last record. In random access, I open the file, I start at the beginning, and then I seek or jump to this data and read it. And that, once again, requires fixed length records, so you can easily calculate where to jump to. That wraps up these slides on reading and writing files. Let's go out and write some programs that write data to disk drives now. Thank you, and I'll see you on the next lesson.